Hey everyone, thanks for joining us today. We're going to do another session for the Good Code Hackathon, if that's what you're here for. We have Jim Barry, a solutions engineer from Esri, here to help you guys out and to get started with any of your Esri integrations for the Jane Goodall Challenge. So I'm going to turn it over to Jim and just say welcome. And if you have questions, please feel free to just post them in the chat here as we go along, and I'll pop them up on the screen for Jim to answer. So Jim, go ahead, take it away. Oh, I think you're on mute, Jim.
Classic stream error. Thanks, Kelly. All right, welcome everyone. Thanks for stopping by. This is quite a task you're taking on with the Jane Goodall Institute Challenge. We'd like to thank the Institute and also, of course, Docusign for allowing us to participate. You want to do good things, and we at Esri want to do what we can to help. Again, my name is Jim Barry. I'm a solution engineer with Esri, and I work in mapping and geographic information systems. I currently work mainly with transit, commuter, and freight railroads and help them do mapping, but I've worked in lots of other industries as well. And for the next 30 minutes, I'm going to get you started with using ArcGIS tools on the web that you can get your hands on now, and resources for you to get productive with them quickly. What we found with app challenges and hackathons is you tend to use the tools that you know. There typically isn't a lot of time to learn new things that you don't already know, because you want to put your time on the problem that you want to solve. So, and we understand that. So if you haven't used ArcGIS before, we want to make it as easy as possible to get some basics under your belt so that you can be productive. Now, if you have any questions or comments about what we're going to cover today, feel free to follow me on Twitter or shoot me an email, and I'll do what I can to help. I've got a lot of information for you. Feel free to use these slides as a reference as you go forward. I've included a tiny CC URL that will link you to the current version of these slides and this video, and there's also a video of this with the most up-to-date information. Now, if you don't have 30 minutes handy and you need to get started right away, here's a URL to a cheat sheet, which gives you everything you need to get the stuff in your hands and get mapping. It has links for how to sign up for a free license, explore what ArcGIS can do, and various ways of getting started, importing data, making and styling maps, building custom apps around your maps and tools. Now, if you're a developer, we have APIs for you. But if you're not a developer, we still have lots of apps, app builders, templates, and other resources for building very customized maps and apps even without code. First, for starters, about us, we are Esri. We were founded in 1969. We are the world's leader in mapping software called Geographic Information Systems, often acronymed as GIS. These are tools from not only making maps, but also for managing spatial data and analyzing it using geospatial science and visualizing those results in various ways, most often on a map. In short, everyone here at Esri are true believers in what this technology can do and has done to improve our relationship with our world, using resources efficiently, improving the lives of people by understanding our world and our impact on it. If you want, you can learn more about what Esri does, why we've been doing it for over 50 years here at Esri.com. Our president and founder, Jack Dangerman, he owns the company. He's a hippie tree hugger from the 60s, and he has enjoyed a long, productive working relationship with Dr. Goodall. So it's extra special that we might be able to help you make your good ideas work well. So what are we going to learn today? Well, we're going to learn what ArcGIS is, and then we're going to get you a free license, and we're going to put it in your hands. Next, I'm going to walk you through some of the basic skills. We're going to follow a data, design, develop pattern, how to get data in, how to make and style an effective map, how to use some analysis tools available on the cloud, and how to share your maps and tools with others, with and without code. In short, ArcGIS, it's a comprehensive set of apps and tools for managing, analyzing, and visualizing spatial data. But it's a lot more than just putting your dots on a map. You can model your world in 2D and 3D. You can detect patterns and help make effective decisions. You can also use modern innovative technologies such as AR, VR, game engines, AI, live streaming data, and then use a wide variety of ways to get your maps and tools into the field using customized apps, dashboards, story maps to anyone, anywhere, anytime on any device. Now, I don't want to get too far down the rabbit hole here, but ArcGIS does offer some heavy-duty desktop workstation and enterprise-class server software. But what we're going to use today are the lighter weight, easier to use options, basically web GIS, where everything's running in the browser and on the Esri cloud, or our SaaS and PaaS, or software as a service, platform as a service system. This diagram here in the upper right pretty much sketches it out. Here at the bottom on the server or on the cloud is the spatial data you'll be mapping and the functional tools for working with it. Then here at the top are a wide variety of devices you can push these maps and tools to. Then here in the middle is a portal tier that you can use to manage that content, manage security, manage users and groups, controlling who can access your content if you want. Here's a quick snapshot of some of the capabilities, some of the basic stuff you can bring into your apps using ArcGIS. Many of you may be familiar with basic mapping things on the web, like finding addresses and creating shortest paths for routing and visualizing your maps in 2D and 3D. And ArcGIS does provide the ability to host your services in the cloud and provides hundreds of thousands of useful data sets that you can include in your apps as well. And then, of course, the special sauce of GIS is spatial analysis and data science. It's more than just visualizing data, it's analyzing it. And all of this is accessible through an engineered set of apps and tools designed to work together and make these capabilities as easy as possible for you to access. So whether or not you consider yourself a developer, for our purposes today, it's the developers.arcgis.com website is what you'll use to access this stuff. Now, while we do have a full set of APIs for the web, for native app development, REST API, Python API, even if you don't understand what those terms mean, this will be the website you'll start with. We have app builders, templates, open source projects that you can download and use for building some pretty customized stuff. So, you ready to go? All right, let's get signed up. So on the developer website, you're going to create a new account by authenticating using one of these other systems like GitHub, Facebook, Google, or just enter your name and email address, and we will activate your license and portal on the Esri Cloud that you can use for web hosting and cloud-based geoprocessing. Now, this is a free license. It's not a trial license. It's a perpetually free license. And because you're participating in this event, you get a lot of cloud credit for doing a lot of stuff. But if you use this voucher code, Docusign Hack 2021, you will get extra cloud credit, which should help you as you're building your products even more. So the key to get starting quickly are a set of tutorials that you can run through in just a few minutes. So when later down the line, when you have your account and you're logged in, on the front page of the ArcGIS developers website, you'll click on a link called Learn and Get Started Building. And this is where you'll start. There are over 100 tutorials here. You only need to get through maybe 3 or 4 of them to get productive. Each one takes about 10 or 15 minutes to go through, hands-on, step-by-step walkthrough. And for each one, especially for the coding ones, there's a View It in CodePen link that brings you to the result. So if you're a coder, right here, you'll find a few tutorials to get you going. First, a Hello World style sample to get an interactive map onto your page. And then 2 more to show a couple of basic location services. In this case, searching for an address anywhere in the world or finding a shortest route with directions. We'll get back to those coding samples here in a bit. But first, before we can do any of that cool stuff, we got to figure out where the data is coming from. So before you can build an app, you have to make a map. But before you make a map, you got to figure out where the data is coming from. So all across the web are open data portals and commercial data vendors that have lots of data that you can use. Now, often finding it is as easy as doing a basic web search. I tend to use keywords like GIS, map, data, download, followed by the special keywords of what I'm looking for, like bike lanes, tree surveys, water samples, weather data, or whatever I happen to be searching for. In addition, your ArcGIS license gives you access to the Esri Living Atlas of the World, where you can search the globe for useful, up-to-date data ready to use with your GIS. Now, another great source of data is the ArcGIS Hub website. Let me make sure. Oh, yeah, ArcGIS Hub website. Government agencies from all over the world use the ArcGIS Hub as an open data portal. Here, I search for Get Food NYC distribution locations across New York City. These locations were established to help deal with the COVID-19 public health crisis. Once I found the data I'm looking for, you'll find that often this data is already published as web services, and you can bring it right into your web map as is. Or you might find that some data sets are just sitting on a data portal on disk or on an FTP site, and you need to download it in one of a variety of formats before you publish it up as web services yourself using your new account. And I'm going to show you how to do that. Yeah, go ahead.
Speaking of new accounts, we have a question here.
Sure.
Someone wants to know, how can we use this voucher beyond what we can do with the free account? And can you paste that answer into the chat?
Well, I'm not in a position to type right now, but what I can tell you this, yes, if you go to arcgis.com and get a free public account, you can't use the voucher for that. So I don't recommend doing that. What I recommend you do is go to our developers.arcgis.com site and get a free account there. That free account is a special developer/cloud account. You could do the cloud storage, you can create services, and it's on this developer free account that you can use the voucher code. The public free account, you can't. Please get your account through the developer website, and then you can use the voucher. Sounds good? I know that's a little confusing, but I just want to be sure. Just go to developers.arcgis.com and you can get that there. Cool. All right, thanks, Kelly. I appreciate it. All right. So next, so this get food data set, in this case, happens to already be published as a web service. So what I do is I grab the REST endpoint URI, which is really just a URL, and copy that to my clipboard. Then in my web map, I paste the URL in, and boom, there's my layer of get food location points. Now, I'm going to walk you through this tutorial. I'm going through fast now, but I'm actually going to do a step-by-step here in a moment. Now, I can even click on a point here on the map to learn more about it. A pop-up opens up, and it tells me more information about that location. So let's learn how to import this data. So now when the data you want to use is already a web service, like it was here with a URL, that's best. But sometimes the data you need is sitting on a server disk somewhere, in which case you need to download it first, then publish it as a web service yourself before you can make a web map and app out of it. So listed here are several of the most common data formats you might find out there. And ArcGIS is ready to import any of them. You may be familiar with terms like shapefiles or GeoJSON and CSVs. These are three of the most common formats. But you might run into these others also, like Excel and KML and GeoPackage and such. So with that in mind, the first tutorial I'm going to have you start with, and this is a very self-paced thing, it's called Import Data as a Feature Layer. So back to the tutorials page, you will find the one called Import Data as a Feature Layer. In fact, the URL is there below. When you get these slides, you can just click on that. And you'll find a short 10-minute hands-on exercise. Now, you just follow the step-by-step, and it'll create 3 hosted feature layer web services on the cloud that are ready for web mapping. In fact, what I'm going to do here in this video is I'm going to run through those same exact steps here with you first. Then I'm going to send you on your way to give it a go to yourself. That way you can see what it's going to look like. So first you log in with your new account, and then you're given a link to download the sample data sets. What you end up with are these 3 data sets. You get a shapefile of parks as polygons, you get a GeoJSON file of trails as polylines, and you get a CSV file of trailheads as points. That way you get to work with 3 different formats, and you also get to work with the 3 basic feature class types in a GIS. So just as a side note, for those who may be new with GIS, we call this a vector-based GIS. And this starts with the premise that everything in the world can be modeled as either a point, a line, or a polygon. So points might be light poles, fire hydrants, street signs, trees. Polylines might be things like street center lines, streams and rivers, water pipes, things that are linear. And then polygons could be things like land parcels, building footprints, city boundaries, things that are kind of an area type of a thing. At that point, once we've modeled and digitized the world this way, then the spatial analysis of GIS that GIS provides is just math. It's just geometry at that point. It's computational geometry, actually. You don't have to, that's all happening in the black box. You don't have to learn all that. But just to tell you, that's what gives us the speed and this accuracy, is we take things in the real world and we turn them into geometry, and from there we can do math on them. Okay, so we're back on track. From your dashboard on the Layers tab is an Import Data button, and again, the step-by-step is going to walk you through this. The tutorial asks you to drag and drop the park shapefile onto the page. Then you set some other properties on this layer. In this case, we're just going to go ahead and take the defaults. Then what happens is the shapefile is uploaded from your disk into the Esri cloud, and a web service with a URL is created from it. Now, we call this a hosted feature layer. There above is the web service URL or REST endpoint. As a shortcut, you can click to open your new layer in a 2D or 3D map. Now, a lot of us may be familiar with the URL on the web. If you click on it, it takes you to a page. Well, we use the same type of model. We still use a URL, but instead of bringing us to a page resource, it brings us to a map layer as a resource, and then we know how to draw that in the map. Or you can use the web service URL and bring that new layer into your map by pasting it in. And here's what it looks like. This web map starts with a base map layer of topography, and on top of that base map is the new layer of parks that you just imported. Now, each park is drawn as a blue polygon. You see a whole mess of blue polygons in there. You can zoom and pan around. Now, if you followed the tutorial just a few more steps, it's also going to have you import the trails as lines and the trailheads as points. Now you have all 3 layers in the map, one on top of the other. In fact, back in the day, before digital GIS, we would make maps this way. Back when I was in college, back long time ago, we would make these layers out of clear plastic Mylar, and we would stick these layers on top of one another, and then you look at your map and you learn about things by looking at that map. Well, now, thankfully, we could do this digitally with computer. Computers are the future. Anyway, so now they don't look at all that great, but next we're going to go through how to style this map in order to make it look better, because it's a pretty ugly map, I must admit. Now, if you don't have the data that you want to map and you can't download it, you can't find it, look, sometimes you got to go out in the field and collect that data yourself. So we have a couple of mobile apps you can run on tablets and smartphones that use the GPS that's built into that device to collect that data yourself, or you can crowdsource that data that you want to map. So now that we have our layers, we have our data, we've created ourselves or we downloaded it, now we're going to make a map, and we're going to make it from existing web services that don't need to be imported first. So from the documentation area of your developer website, you at some point are going to find a tutorial called Create a Web Map. There's the URL here below. It takes about 10 minutes to do. It's very step-by-step, but if you want, you can click the View Solution link there on the right in order to see the finished product. So here in this tutorial, you're given 4 REST endpoint URLs, and one at a time, you're going to add them to the map using the add layer from web menu item. So here on the right, if you want, you can even swap out the base map layer. You have lots of choices. Esri provides a few, like the topography, like streets layer, a subdued light gray layer, or even satellite imagery or OpenStreetMap even. You can lay it down there. Whatever serves your map the best. So in the end, you end up with a similar map, a topographic base map and layers for parks, trails, and trailheads. If you click on any of these features, a pop-up shows you more information about each one. Now, again, that's a pretty ugly map. Let's make this map look better and also make it more intuitively useful. Here's the third tutorial that I'm going to have you do. It also takes 10 minutes. It also gives you a step-by-step process. And it walks you through doing this process that we call attribute-based symbology. And basically what that means is we're going to give the features automatically. We're going to give them different colors based on information that's in its attribute table. If you don't want to walk through this, you can always click the View It Live link, and it'll show you the solution. Now, you may have noticed that by default, each trailhead is this small circle, perhaps a green or orange circle. But regardless, this tutorial shows you how to apply a more useful point marker. In this case, why not change each circle to a little graphic that looks like a hiking sign? And now each trailhead point is given a hiking sign marker. This is one small way of making your map more intuitively useful. Now, if someone grabs your map and they see the hiking symbol, they can say, oh, it's probably a trailhead or something having to do with hiking. Next, the tutorial has you apply some symbology to the line layer. Each trail polyline is associated with a record in that layer's table. And one of those values represents the number of feet of elevation gain there is along that line. So ArcGIS lets you apply a rule that says, hey, the lines that are very steep, give it a very thick line, and lines and trails that are just not steep, give it a very thin line. And this makes the map even more useful. So if I'm hiking or biking and I want to challenge myself, I can find the thick trails. If I don't want to challenge myself, I can find the thin trails, and that makes the map more useful. So let's apply a rule to the parks layer. There's different kinds of parks, and each park has different rules for going there. Some parks I can just show up. Some might need a pass or permit. Some trails I can hike on, but don't allow my bike. Let's apply a rule that helps using a column in the parks layer called type, as in type of park. So what ArcGIS does is it scans through that data set, and for each polygon, it chooses a color based on that rule. Here you can see the natural areas are in purple, the regional open spaces in green, local parks are in blue, and so on. You can change these colors if you want, or you can just take the defaults. It's totally up to you. Now, if I click on one of these trailheads, a pop-up opens with more information about that trailhead. Now, if you look at this pop-up, it's a little rough. It's a little cryptic there. It's not a lot of styling. It uses the actual database column names, which are cryptic and aren't very easy for the general public to use. But the map lets you configure this and customize it a little bit. And it lets you say, hey, which of these columns are editable, which are viewable, which are hidden. And you can give it some alias names. So now you see the same pop-up, but the field names are a little bit more useful for people that are looking at your map that don't understand the column names. Let me see. You could add, if you wanted, a tabular grid type appearance, or if you're a designer, this little pop-up window also, not fully, but to a great degree supports HTML and CSS. So you can, and it's a web page, so you can actually style this pop-up using some HTML and CSS as well. All right, so now you've created your map. Callie, how we doing on questions? All right, I'll take that. I'll take that. No news is good news. All right, so now that you've made your map, let's figure out the ways to share it, because I imagine you're going to be sharing your map as a part of the project that you're doing. So when you're in the map viewer, there's a share button that you can use to control access to your map. By default, all of your work starts out as private and only you can see it. But you can also share it to a defined group of people or everyone in your organization, or you can even share it on the open internet with anyone in the world. There's also social media links and a special ArcGIS URL shortener. If you're creating your own web page or perhaps writing your own blog article, we even create you an iframe HTML tag so that you can copy paste that iframe HTML into a page so that you can embed a live interactive view of your map into that page. There's also a button for wrapping a custom web application around your map. There's a couple of dozen configurable web app templates that ArcGIS will create for you. And then you can share your map as a web application. You bring it the map, we wrap an application around it, and then you share that application. You haven't written any code in doing so. So elevation, let's take a look at one of these. Elevation profile, it's one of the many templates you can choose from. Now, this one seems appropriate for us since we've been working with data related to parks and trails. Here is what that configurable app template looks like when it wraps around my map. This took me literally 5 minutes to do. Now, when I choose a trail, what it does is it makes a REST call to an elevation profile web service that converts that trail into a sideways looking elevation profile. So that is actually what the elevation is going to look like if I'm biking or hiking or running or whatever. If I'm going to hike and bike, it's a really neat way to see the hills that are in my near future. Now, this is now a very useful yet very simple web application. The trailhead markers are intuitive. The lines have thickness. The type of park is given to me. And just by clicking on it, I see the elevation profile. I didn't have to give the user instructions. So ArcGIS gives you several other ways to create some really customized web app experiences, most of them without writing any code. This helps get your maps and tools out there most quickly. Here are 4 of them that I wanted to share with you real quick. Web App Builder and Experience Builder here at the top are widget-driven apps that are click and drag. They run right in your browser. You don't have to install anything, and they walk you through building robust websites, and sometimes only take a few minutes to create. Here at the bottom, story maps are another really great way to get your maps out, not just relying on your end user's ability to understand from your map what you hope they'll understand, but when you can tell your own story along with your map, that can communicate much more effectively. And then finally, dashboards are also a very popular way to create a web app that helps consume volumes of information in a very digestible, easily understandable way. For example, here's a dashboard you may have seen recently on the web or on the news. Johns Hopkins University used ArcGIS, our software, to visualize the volumes of public health data in a very easily understandable way. At a glance, you can see the current state of things as well as trends over time. What you do is bring your map into the dashboard. Then you use this menu list of elements that you can click and drag in, resize, and connect data feeds and action triggers to. Web App Builder lets you bring in your map, choose a theme, colors, and labels for your web page, and then also choose from several dozen widgets to give your end users only those tools you want them to have. That way they can get to work and they don't have to spend time trying to learn how your app works because you designed it for them. Click and drag for what they need to do. If you want to give them your map and only these tools, directions, edit, measurement, print, then that's all you give them. Makes it very easy for them to do. Now, once you create this app, you can preview what your app is going to look like on a wide variety of devices. That way you have time to adjust things like line thicknesses, label sizes, and tool widget locations before you deploy your app out there on the cloud. Web App Builder has responsive design automatically built in so that the app that you build, it's going to look great, whether you're on a large desktop monitor, on a tablet, on a small smartphone, in portrait or in landscape mode. We have built that design, responsive design, in automatically. Now, that's Web App Builder for web apps. We also have the similar type of thing if you want to build native apps like iOS apps or Android apps. App Studio is a codeless, template-based way to create custom native apps for your maps and tools. For example, for Windows, for Apple devices, Linux, Android, and more. Java, what have you. Build your app once and then compile it cross-platform or for different platforms. You can deploy that within your organization, or you can sell your app on the various app stores. So, okay, developers, get ready. Okay, sure, there's a lot of no-code ways to build custom apps, and I covered a lot of those, but developers often want the API. Where's the API? They want to code things themselves, and that's great. Okay, let's do that. So when you're logged into your developer account, you'll see a wide variety of APIs that you can use depending on what kind of app you're building. The REST API is one. That way you can make individual REST calls, get and post requests, get images back, get maps back, get JSON back, however it works. Most of our APIs, whether they be for the web or native devices, they wrap around or are based on our core WebGIS API called the REST API. So even if you're using one of those other more specific APIs, you always have the ability to make these lower level calls to web services using the REST API. For example, here's a short list of some of the location services exposed by the REST API. While ArcGIS offers more robust APIs for those variety of platforms, sometimes you don't actually need a physical map, or sometimes you don't want to load any libraries, or you don't need all that overhead. You just need to make a single REST call and a single REST return. That's where the REST API comes in really, really well. Like here, here I'm using Postman, which is a very convenient way to test REST calls, to test this simple HTTPS GET request to the Esri World Routing Solver in order to get some JSON in return. Now, what I do is I pass in 2 latitude, longitude point locations, and those are our stops. We're going to start here. We're going to stop there. And I put those in the URL parameters to this routing service. That service finds the shortest path and returns to us some JSON containing all kinds of information that we can use. The geometry of the linear path, locations, distances, turn-by-turn directions, all that stuff comes back from the service. And you can parse that JSON yourself if you want to. So you have a lot of low-level access to that. If you're a web developer, while we do have a JavaScript API that wraps around the REST API to some degree, and I'll get back to that in a moment, we also have an open source JavaScript library, which makes using the REST API easier to use. For example, here's the documentation and tutorial for how to make that same shortest path route request that I just talked about, except instead of making that REST call yourself, you bring in the REST.js API and you make a JavaScript. You make that request through that API. Here's some code from the short tutorial that shows how to use this REST.js library in your apps. It's a very hello worldy way to go. You can just copy this in, paste it, and expand from there to call a wide variety of content services, wide variety of location services. This one, again, being routing. So see here, I reference the libraries that we provide. Let me see. Look at my mouse over here. I got the libraries that we provide. We bring those in. Let me see. I put in my API key. We make it asynchronous promise call to the API's solve route method. And then on return, we parse out the return JSON. Here's the return JSON. We parse that out, and then we do whatever we want with it. I can put a point here, and then draw that line on the map. So you could do this without code, but if you want to do it with code, we try to make it as simple as it can be. Let me see here. Let me get my mouse back here. Okay, so next, what about a JavaScript API? You bet. So the JavaScript API is the most popular, most used API amongst our global developer community. It's very easy to learn. It's very robust. There's a couple of dozen tutorials, and all of them can be used standalone in CodePen, or you can copy paste them out into your web development environment. Our API supports the use of TypeScript if you want. It's also being used along with all of the popular web frameworks, both older ones like Dojo and jQuery, but also newer ones like React and Angular. The JavaScript API page on the developer website has hundreds of runnable code samples that you can learn from or cobble together. In fact, a lot of applications that I build, I start with these samples, I cobble them together, and then I tweak them. In fact, I write at these applications all the time, and very rarely am I writing raw code from scratch. It's really, this API has been around a while. It's really more an exercise of finding something out there that's close and then tweaking it to fit you. So in that, you can save a lot of time. Okay, so let me see. So each sample can dump out the code pen so that you can work with it there, or you can modify it, see its behavior before using it. For example, here's a line of sight widget, and it works in a 3D scene view map as opposed to a 2D map. Now with it, you can analyze whether or not various points on the ground can be seen from some vantage point up in the air, like from a building or vice versa. The sample code in CodePen lets you try out the widget before pulling it into your code base. In fact, I did this one application once in New York City where we made a map and we said, okay, here's a 3D volume of where 4th of July fireworks are going to be. Let's make a map that shows all of the locations in the city, particularly parks, where you can and cannot see those fireworks. And then you put out that map so that people know where to go, so that they get a good vantage point. It's a 3D volumetric view shed analysis for doing that. Very robust. So if you're already using one of these web APIs, for example, Leaflet or OpenLayers, or if you're building apps with Mapbox, you can still use, you don't have to use our APIs. You can still use our location services and use our data services and plug those in. We have lots of sample code that you can paste in and run with OpenLayers, Leaflet, and Mapbox. Just insert your API key and go. For example, here's a Mapbox GL.js based app. What you're seeing here is a Mapbox map component, Mapbox tiles, and a Mapbox pop-up. But within the pop-up is data that comes from Esri's reverse geocoding service. Just a quick hello world type approach to pulling in Esri location services into other map technologies and open source tools. Now, I mentioned before about an API key. Now, the way to access these location services from Esri, regardless of which development tools you use, is to create an API key for yourself, add that key to your code, and then those services and APIs just light up. So that's great if you're doing web development, but how about for native apps? ArcGIS comes with a set of runtime SDKs. If you're already building an application with Visual Studio, Android, Java, iOS, and Qt, all of these SDKs are based on a C++ core that provide all the core functionality, and then we build an SDK around it so that these capabilities fit into the normal conventions of each type of development. Each runtime SDK has a half dozen or so tutorials, just like I showed you before. You can bring those right into your IDE, like Xcode, Eclipse, Visual Studio, Qt Creator, whatever. There's also a growing list of open source projects for runtime apps that you can bring in, compile as is, or you have the source code for extending those further. They're a very good starting point. Let's say you're a data scientist using Python. ArcGIS provides a Python API that has Python packages for connecting GIS capabilities to the work and analytical projects that you do. Same as the other APIs, there's some very quick 5, 10, 15-minute tutorials for getting started, for helping learn some common tasks like creating map layers, creating and sharing maps, doing statistical analysis, location services, routing, geocoding. They're all accessible from this Python API. Each of the tutorials, you can run those as Python scripts. I prefer to run them in Jupyter Notebooks, makes it a lot easier to make things really interactive and easy. We fully support that, or you can bring these samples into other Python dev tools and IDEs and editors like PyCharm or Spider or whatever you want to use, you can use. Then when you want to start adding GIS to your data science, you're doing data science, but what about the spatial part of it? When you want to bring the spatial into that analysis, there's a growing list of sample notebooks, lots of them. Some of them are shown here. Each one of these is a Jupyter notebook that you can, I almost said steal. You can borrow, copy, paste, and learn from. Yeah, you can steal them. I steal them. You learn some best practices for using GIS in data science. The ArcGIS API for Python also includes modules that wrap up some of the more popular AI capabilities for machine learning, deep learning, and more. Here's some examples for doing feature detection on images and video using deep learning. On the left, we're detecting vehicles and pedestrians. And on the right, we're using deep learning to count and categorize the number and type of rail cars as trains arrive and depart from a maritime port. All we need to do is train that deep learning model, teaching it what a locomotive looks like, what a boxcar looks like, what a flat car looks like, shipping containers. And after that model has been trained, we are now fully automating a process it used to take people to do, and often in a much more accurate way. And even then, you don't even need to always train the deep learning model. Out on the living atlas of the world, there are dozens of pre-trained deep learning models that you can use as is in order to do feature detection, operational awareness, system, spatial analysis, stuff that we train that you can use right out of the box. Since if you worked with AI, you know sometimes training a deep learning model takes a lot of data, takes a lot of time. So in a lot of common use cases, we've done that for you. So that's about the capabilities of the product, but what about the community? You know, when I'm looking at a new technology, yes, I want to know what it costs. In this case, for you, it's free. I want to know the capabilities, and hopefully I showed you a lot of those capabilities. But the third C for me, cost, capabilities, is community. Where's the community? Who can I borrow great ideas from? Who can I ask questions of? As I'm learning a new technology, any problem I run into, chances are someone's already run into that problem and they've already posted that question. The community's already answered it, and the best answers bubble to the top. If you use Stack Exchange or Stack Overflow, we also have this Esri community that you can do as well. There's a couple of hundred topical community areas that you can learn from. Good, and if you search for your question, you find the question, you find an answer, you're off and running. So it's a very, very powerful productivity tool. The global Esri developer community also contribute to the hundreds of open source projects that are built on the ArcGIS platform that you can download and use. It's not just apps, but you can find samples, libraries, templates, tools, add-ins, and much more. So let me see. Once again, here's this URL to the slide deck cheat sheet that you can keep handy. Here is the URL for these slides. There's also a URL for the video version, which basically covers the same ground that I did. I'm going to leave this up a little bit, but I'm sure we can paste that into the chat as well. And then let me go back. So, hey, that was a lot. And I know it was a fire hose, and I hope I didn't bore you. But, like I said before, you tend to use what you know, in these types of activities. But if you want to use ArcGIS and you don't know it, I really just wanted to emphasize that there's a lot of very basic things that you can learn to do in 5 or 10 minutes. The community is there to help. I'm there to help. Mentors are there to help. If you get stuck, we want to make sure that you don't stay stuck. And if you have a good idea, we want to make sure you can make that good idea work, particularly because, it's the Jane Goodall Institute Challenge. Esri has a very strong working relationship with this organization. We want you to succeed. We want you to do good things, makes you look good, makes us look good, and does a lot of good in the world. So that's about all I had. Again, thanks for your attention. And I really look forward to seeing what kinds of things you build. And if you build them with ArcGIS, better. If you don't, that's good too. I'm just really excited to see what comes out of this. So that's what I had.
Thanks so much, Jim. And just to everybody else, again, that was Jim Barry at Esri, and I put the sign-up links for the hackathon in the chat. So we're going to wrap up now, but if you have any other questions, please take it over to the hackathon Slack, and we'll catch you there. Thanks again, Jim, and see you all later.
Thanks, Kelly, and thanks, everyone. Good luck and have fun.